14.2 is multiplying and dividing rational expressions. So the first part we'll be dealing with is multiplying and simplifying. Remember, simplifying just means, that all we're going to be doing is reducing the fractions. So I'm going to scroll down just so you can see the third problem, because I want you to notice a difference between the first two problems, this one and this one, compared to that one, okay? So in the first two problems, what we have are what we call monomials, because each part of our fractions are single pieces, okay, like 3x, y squared, things like that. Whereas when I look at the third fraction down here at the bottom, the denominator on the first fraction is 2x minus 14, right? That's a binomial. There's two terms there. So in doing these problems, when I have monomials, in my opinion, the easiest way to do these problems is just to multiply straight across. So 3x times 7y is going to leave me with a 21xy. Okay. On the bottom, y squared times 4x will leave me with a 4x y squared. I'm just putting them in alphabetical order. All I'm going to do now is just reduce my fractions, okay? So this x and this x will cancel out. 21 and 4 will not, so I'm going to leave those alone. If I look, on the top I have a y, on the bottom I have a y squared. So I have an additional y down here. So one of this y here will cancel with one of those y's, but I'm still going to have one y left over, right? Okay. Let's do the same thing here on this next problem. So again, I'm just going to go straight across. 9x squared times 4y will leave me with a 36x squared y. Y times 3x to the third will leave me with a 3x to the third with a y. Okay. Come back here. Okay. First thing I notice, 3 goes into 36, nice and neat, 12 times. Okay. When I look at my x's, I have an x squared and I have an x to the third. So there's one extra x on the bottom. So there'll be an extra x on the bottom here. And then this y and that y will cancel out. And so there's my final answer. Okay. So now, let's take a look at this next problem. This one's going to be slightly different because they're binomials here. So my first step is I'm going to look at the top. X, I can't do anything with that x, so I'm going to leave it alone. Over here, 2x minus 14, I notice that I can factor out the number 2. So I'll write that as 2, and then parentheses x minus 7, times, we'll do the same thing here. We can factor out an x. We're left with an x minus 7. At the bottom, we just have a 5. Okay. So now this x minus 7 and this x minus 7 will cancel each other out. Okay. We're going to multiply straight across, so x times x will leave me with an x squared, and 2 times 5 will leave me with 10. Okay. All right, so for my next problem here, let's take a look here at the top. 6x plus 6, I can factor out the number 6, and I'm left with an x plus 1. That's just a 5. That's just a 10. On the bottom here, we can factor out a 36. We're left with an x plus 1. Okay. So now, again, this x plus 1 and that x plus 1 will go ahead and cancel each other out. Let's see what else we can reduce. Looks like we can reduce some numbers. So 6 goes into 6 once. 6 goes into 36 6 times. Okay. 5 goes into 5 once. 5 goes into 10 2 times. Okay. I'm just going to multiply straight across. So all this is canceled. I have 1 times 2. Well, 1 times 2 is just 2. On the bottom, this and this and this is all canceled. So I just have 1 times 6. It's just 6. And finally, we can reduce 2 over 6 to 1 over 3. All right. Let's take a look at this next problem here. Okay, x squared minus 25. I'm going to use my difference of squares formula. X minus 5 and x plus 5. Okay. For the bottom part here, let's see, 1 times negative 10 is a negative 10. So 2 and a minus 5 multiplied to negative 10, they add up to a negative 3. So that's an x plus 2. That's an x minus 5. Okay. On the top over here, I still have an x plus 2. We got an x right there. All right, so let's see what's going to cancel out. So x minus 5 and x minus 5, those will cancel out. X plus 2 and x plus 2, those will cancel out. So on the top, I still have an x plus 5. On the bottom, we still have an x. So let's try this next one here. If you notice, there's 4 polynomials, but because the coefficient on each of them, the leading coefficient is a 1, meaning the number in front of the x words are 1, I can use my shortcut in this case on every single one. Okay. So let's see. 1 times 8 is 8. What two numbers multiply to 8 and add up to 6? 2 and 4. Okay. So that's going to be an x plus 2 and an x plus 4. Okay. Same thing here. 1 times negative 20. Negative 20. That number there is a positive 1. So I'm going to use 4 and 5. Make that one a positive 5 and a negative 4. They multiply to negative 20, add up to a positive 1. So that's going to be an x minus 4 and an x plus 5. Okay. Let's do the same thing for this one here. 1 times negative 15. Negative 15. Okay, what two numbers multiply to negative 15 add up to a positive 2? Negative 3 and positive 5. So x minus 3 and x plus 5. Okay. And finally, 1 times 16 is 16. What two numbers multiply to 16 and add up to 8? 4 and 4. I'm going to go ahead and write both of them out. I don't want to write x plus 4 squared just yet. I think it makes it easier if I see all the terms. All right, so now we're going to look for the terms that are going to cancel out. All right, so let's see. I have an x plus 4 here and an x plus 4 here, so that one and that one will cancel. Let's see. We have an x plus 5 right here and another x plus 5 right here, so those will cancel. And it looks like that's all that's going to cancel out. So I'll still be left with an x plus 2 and an x minus 3 all over an x minus 4 and an x plus 4. All right, good deal. All right, so the next part of 14.2 is how do we divide and simplify? Okay, so if you remember in dividing fractions, the first fraction stays as it is, 5x to the 7th, or 2x to the 5th. The division sign becomes a multiplication, and we take the reciprocal, meaning we flip that fraction. So that's going to become 4x to the 3rd over 15x. Okay? Just like we did earlier in 14.2, since these are all monomials, I'm just going to multiply straight across. Okay, so let's see, 4 times 5 will leave me 20. X to the 7th and x to the 3rd, we're going to add our exponents, x to the 10th. Okay. 2 times 15 is 30. X to the 5th and x is x to the power 6. Okay. Now we can go ahead and worry about reducing our fractions. So 20 and 30, I can divide them both by 10. That's 2 and that's 3. I have 10 x's on the top, x to the 10th, and x to the 6th on the bottom. So there's 4 more x's on the top. So that's an x to the 4th. And we're done. Okay. So let's do this next problem the same way. I'm going to go ahead and start factoring from the beginning. So 1 times 10 I know is 10. And the two numbers that multiply to 10 and add up to 7 are 2 and 5. So I'm going to go ahead and write that as x plus 2 and x plus 5. Okay. Then x minus 1 will stay on the bottom. And it changes to a multiplication. We're going to take the reciprocal of that fraction. So I know my x minus 1 is going to come to the top. But I need to factor the top part, which is now going to be my new denominator, right? So 1 times negative 15 is a negative 15. So we can use 3 and 5. That's a positive 2. That needs to be a positive 5 and a negative 3. So x minus 3 and an x plus 5. I think the hardest part in doing these problems is just the factoring, because this part should be the easy part, right? You can see, okay, look, x plus 5, those cancel. X minus 1, those cancel. Notice when I'm canceling my factors, one's on the top, one's on the bottom. They don't have to be diagonal, but one has to be on the top part, one has to be on the bottom part. So what are we left with? An x plus 2 over an x minus 3. Okay. So let's try this next one here. Again, m squared minus n squared, that's just my difference of squares formula. M minus n, m plus n. Okay, I already have an m plus n on the bottom. We're going to change this to a multiplication, and we're going to flip our fraction. So this m is going to come down here. I'm going to look at this part, and I notice right away we can factor out the letter m, and we're still left with an m plus n. So now, okay, let's see what we can group here. So look, this, oops, let me get a different color. So this m plus n and this m plus n. I can cancel one on the top, one on the bottom, okay? It doesn't have to be this one here. It could be, but it doesn't have to be that way. Those will cancel. These m's will also cancel. They're single individual m's. And so now all we're left with is on the top, m minus n, m plus n. On the bottom we're left with a 1, but remember we don't write the 1 in the bottom. So m minus n and m plus n, right? Okay, great.